क्लासेस हो गया अभी सर दर्द तेरा अब good afternoon students. Good afternoon students. Let us continue with mathematical induction. Already we finished yesterday 4-5 sums. Now let us finish off remaining 4-5 sums including divisibility also. Let us finish off including divisibility also. Okay, right. Now prove by mathematical induction. Prove by mathematical induction. A plus D, A plus 2D plus so on plus up to n terms. So on plus up to n terms is equal to n by 2 into 2a plus n minus 1 into d. This is the statement. Again, your nth term is missing in this statement. Let us find the nth term. So let S of n be the statement. Let S of n be the statement. That is a plus d plus a plus 2d plus so on plus nth term is missing here. Your nth term is nothing but a plus n minus 1 into d, which is in arithmetic progression, which is nothing but arithmetic progression. He has given this sum in 2-3 times till now. Is it clear? N minus 1 into d, n by 2 into 2a plus n minus 1 into d. Is it clear? So your nth term is nothing but a plus n minus 1 into d. This is your nth term. This is your nth term. Okay. Now for n equal to 1 first. For n equal to 1 means your LHS. That is nothing but a. In your RHS, that is nothing but put n equal to 1. That is 1 by 2 into 2a plus 1 minus 1 into d. 1 by 2 into 2a plus 0. That is 2a by 2, which is nothing but a. See, I got LHS equal to RHS. Therefore, the statement S of n is true for n equal to 1. Therefore, the statement S of n is true for n equal to 1. Now assume the statement. Assume the statement P of assume the statement S of n is true. Assume the statement S of n is true for n equal to k. Wherever you find n, you put k. I said a plus d, a plus 2d plus so on plus what was your nth term? A plus n minus 1 into d means a plus k minus 1 into d. This is your nth term. That is equal to k by 2 into 2a plus k minus 1 into d. This I will put it as equation 1. 2a plus k minus 1 into d. That you will put it as equation 1. Now, to prove the statement, S of n is true for n equal to k plus 1. For that, what I should do? Add k plus 1th term on both sides of 1. Add k plus 1th term on both sides of 1. Now, how to get k plus 1th term? Already I told you. In your nth term, instead of n, you put k plus 1. So what I'm going to get? A plus 1 minus 1 into d. That is a plus kd. These two gets cancelled. So add this term to equation 1. That is a plus d plus a plus 2d plus so on plus a plus k minus 1 into d plus a plus kd is equal to k by 2 2a plus k minus 1 into d plus a plus kd. Is it clear? So I added this term on both sides of 1. Same thing I added on both sides of 1, correct? Now we are going to simplify your LHS part. Now I multiply k by 2 inside. 2 gets cancelled. A by k. Sorry. 2 gets cancelled. What I will get? Ka. Correct, no? 2 gets cancelled. Ka plus k into k minus 1 into d. This is by 2 plus a plus kd. Okay, let us see the simplification. I multiplied k inside. Okay, you do one thing. Let us take k LCM only. Let us take 2 LCM first. That is much better way. K by 2 I said no. Take 2 LCM. That is 2ak plus k into k minus 1 into d plus take LCM 2. 2a plus 2kd. It's whole divided by 2. It's whole divided by 2. Now that is equal to, once again I write the same step, whole divided by 2. What it was? 2ak plus k into k minus 1. So k square d minus kd. I will write it as 2ak plus k square d minus kd. Correct now? 2ak plus k square d minus kd plus 2a plus 2kd plus 2a plus 2kd by 2. Okay, so 2kd minus kd is kd. So 2ak plus k square d plus 2a plus kd whole divided by 2. Now I am going to take 2ak and 2a common. So 2a common, k plus 1. And 1 kd common, k plus 1. I am taking from these two terms, right? So this, I'm taking here and here 2a common. And I am taking here and here kd common. Okay, no? Right. So that is nothing but by 2. Now I'm going to take k plus 1 common. Then 2a plus kd by 2. That is nothing but k plus 1 by 2 into 2a plus, for this k, add 1, subtract 1 into d. See, it is in the form of n by 2 plus 2a plus n minus 1 into d. Right? Instead of n, I got k plus 1 or not? Therefore, the statement S of n is true for n equal to k plus 1. Therefore, by mathematical induction, the statement S of n is true for n belongs to capital N. N belongs to capital N. Same problem, there is one in geometric progression. Okay, that part Okay, never he asked this arithmetic progression only he asked most of the times. So in geometric progression part, you can do it, but very least important that is. Okay, next. Prove by mathematical induction. Prove by mathematical induction. Now, what is that? 1 by 1 into 4 plus 1 by 4 into 7 plus 1 by 7 into 10 plus so on up to n terms, that is equal to n by 3n plus 1. Let S of n be the statement. Let S of n be the statement. What is that statement? 1 by 1 into 4 plus 1 by 4 into 7, 1 by 7 into 10 plus so on. Right? Now, up to n terms. Up to n terms is n by 3n plus 1. So your nth term is missing. In the product here 147. 147 dot dot are in AP. So Tn is A plus n minus 1 into D. 1 plus n minus 1 into common difference is 3. 1 plus 3n minus 1 plus 3n minus 3. 3n minus 2. Right? Next 4, 7, 10. 4 comma 7 comma 10 red dot are in AP again. So Tn 4 plus n minus 1 into again 3. 4 plus 3n minus 3n plus 1. Now therefore your nth term is what? Your nth term is 1 by 3n minus 2 into 3n plus 1, correct? Now this is your nth term. 1 by 3n minus 2 into 3n plus 1. Now write down once again the statement. Therefore 1 by 1 into 4 plus 1 by 4 into 7 plus 1 by 7 into 10 plus so on plus 1 by 3n minus 2 into 3n plus 1 is equal to n by 3n plus 1. This is your statement. Same. First for n equal to 1 in LHS 1 by 1 into 4, 1 by 4. RHS 1 by 3 into 1 plus 1, 1 by 4 only, no? 3 into 1 is 3, 3 plus 1 is 4. Therefore, your LHS equal to RHS. Therefore, the statement S of n is true for n equal to 1. Now assume the statement S of n is true for n equal to k. Whenever it says the statement is true for n equal to k, substitute 1 by 1 into 4 plus 1 by 4 into 7 plus 1 by 7 into 10 plus so on plus 1 by 3k minus 2 into 3k plus 1, that is equal to k by 3k plus 1. In this you will put it as 1. Is it clear? Instead of n, you have to put k. That is only your assumes statement that it is true for n equal to k. Now, to prove the statement, S of n is true for n equal to k plus 1. True for n equal to k plus 1. Means for that what I should do? Add k plus 1th term. Add k plus 1th term on both sides of equation 1. What is your k plus 1th term is? The k plus 1th term is 1 by k plus 1th term is 1 by 3n minus 2, 3n plus 1. That is 1 by 3 into k plus 1 minus 2 into 3 into k plus 1 plus 1. Is it clear? That is 1 by 3k plus 3 minus 2 into 3k plus 3 plus 1. That is 1 by 3k plus 1 and 3k plus 4. This term you are going to add on both sides of 1. What is that 1? Therefore, 1 by 1 into 4 plus 1 by 4 into 7 plus 7 into 10 plus 1 plus 1 by 3k minus 2 into 3k plus 1 plus, now I'm changing the color. What I'm going to add is 1 by 3k plus 1 into 3k plus 4. That is equal to k by 3k plus 1 plus by again 1 by 3k plus 1 plus 3 into 3k plus 1 into 3k plus 4. See, I added both sides k plus 1th term. Now take your LHS, RHS and try to solve it. So what was your RHS? K by 3k plus 1 plus k by 3k 1 plus 1 by 3k plus 1 into 3k plus 4. Now start simplifying. 1 by 3k plus 1 common. What is left out? K plus 1 by 3k plus 4. That is 1 by 3k plus 1 into 3k square plus 4k plus 1 by 3k plus 4. Now I am going to factorize the numerator. 3k plus 1 into 3k square plus 3k plus k plus 1 divided by 3k plus 4. That is 1 by 3k plus 1 into 3k plus 1 into this is k plus 1 by 3k plus 4. Now 3k plus 1, 3k plus 1 gets cancelled. So what is left out? Here I am finishing off. K plus 1 by 3k plus 3 plus 1. This 4, I will write it as 3k plus 3 plus 1. That is nothing but k plus 1 by 3 common k plus 1 plus 1. If you observe it, instead of n, I got k plus 1. Check it. Instead of n, I got k plus 1. Therefore, the statement S of n is true for n equal to k plus 1. True for n equal to k plus 1. So therefore, by mathematical induction, the statement S of n is true for n belongs to all natural numbers. That was only your mathematical induction says. Is it clear? That is how you are going to do this. Let us see divisibility sums. Mathematical induction, divisibility sums. Those are your number sums in mathematical induction, which are very, very important. Almost all everything has been done. Now prove that. (49 power n plus 69 minus 1 is divisible by 64. Prove that. Prove that 49 power n plus 69 minus 1 is divisible by 64 or not. Is it clear? announce. See the solution. Let S of n be the statement. This is a different way of doing the sum. Let S of n be the statement. What is that statement? 49 power n plus 69 minus 1 is divisible by 64. So this is just statement. Is divisible. 49 power n plus 69 minus 1 is divisible by 64. Is divisible by 64. Not for that, let us for n equal to 1. 49 power 1 plus 16 into 1 minus 1. 49 plus 16 minus 1. 65 minus 1, 64. Yeah, is 64. Yeah, when I substituted 1 here, what I got is 49 power n plus 69 minus 1. That is 49 plus 16 minus 1. Instead of n, you put 1. So you get 65 minus 1. It's nothing but your 64, right? Is 64 is divisible by 64, correct? No? Yeah, 64 is divisible by 64. Therefore, the statement S of n is true for n equal to 1. Therefore, the statement S of n is true for n equal to 1, because when I substituted n as 1, I got 64. Is 64 is divisible by 64? Yes. 64 is divisible by 64. Now, assume the statement S of n is true for n equal to k. It means what? 49 power k plus 16k minus 1, I will write directly, is divisible by 64. 49 power k plus 16k minus 1 is divisible by 64. I will write directly. It means, therefore, 49 power k plus 16k minus 1, 64 into m, because it is exactly divisible. Now, 49 power k is equal to 64m minus 16k plus 1. 49 power k should be the subject. You have to make it as subject always, right? So 49 power k plus 16k minus 1 is 64m. It means 49 power k, you will make it as subject, 64m minus 16 plus 1, right? This I will put it as 1. Now, to prove the statement S of n is true for n equal to k plus 1. For that, what I am going to do? Instead of n, I will put k plus 1. That is 49 to the power k plus 1 plus 16 into k plus 1 minus 1. But I will not directly write is divisible by 64. I will not directly write is divisible by 64. Is it clear? Let us simplify this part. That is equal to 49 power k into 49, split up, plus 16k plus 16 minus 1. Now, what is 49 power k? Your 49 power k is this much. Your 49 power k, you are going to replace with that. What is that? 64m minus 16k, 64m minus 64m minus 16k plus 1. Correct, no? Plus 1, right? Into 49 plus 16k plus 16 minus 1 is 15. Now, 64m into 49, this is okay, minus 49 into 16. 49 into 16. That is 49 into 16k plus 49 plus 16k plus 15. Is it clear? Right. Now 64m into 49 minus 49 into 16k and here plus 1 16k, correct? So what I'm going to get there? 16k common minus 49, 16k common minus 49 plus 1 minus 49 plus 1 plus 64. Is it clear? That is 64m into 49 minus 16k into minus 48 plus 64. Is it clear? So here it is plus. So here it is plus. Now 64m into 49. Correct? No? Right. Here I am going to take minus 12k into 64 plus 64. Now you take 64 common. Then what I will get? 49m minus 12k plus 1. 64 into 12 and 16 into 48. We'll get both the things same. Is it clear? Right. So minus 12k, which is nothing but 64 into some integer, you will get it. Right? Therefore, here it is 49 to the power k plus 1 plus 16 into k plus 1 minus 1. Right? Therefore, Therefore, 49 to the power k plus 1 plus 16 into k plus 1 minus 1 is divisible by 64. Therefore, the statement S of n is true for n equal to k plus 1. Therefore, the statement S of n is true for n equal to k plus 1. Therefore, by mathematical induction, the statement S of n is true for n belongs to natural numbers. Your n belongs to natural numbers. Is it clear? There is one more divisibility sum. Let us do that also. Prove that 3 into 5 to the power 2n plus 1 plus 2 to the power 3n plus 1 is divisible by 17. We have to prove this by mathematical induction. Is it clear? We have to prove this by mathematical induction. Now, see this. Let S of n be the statement. Let S of n be the statement. Let S of n be the statement. What is that statement? Let S of n be the statement. What is that statement? It says 3 into 5 to the power 2n plus 1, 2 to the power 3n plus 1 is divisible by 17. That is a statement. First, I will put n equal to 1. N equal to 1 means what? 3 into 5, 2 ones are 2 plus 1, 3. Cube plus 3 into 3 ones are 3 plus 1. That is nothing but 3 into 125 plus 2 to the power 4. That is 3 5s are 15. 3 2s are 6 plus 1 7, 3 1s are 3. 2 power 4 is 16. Now add them. 6 plus 5, 11. 7 plus 1, 8 plus 1, 9. Right. Is 391 is divisible by 17? Yes. 391 is divisible by 17. How many times it goes? See, 391 divided by 17. 17 twos are 34. 34 means 5 will be left. 51. 17 fours are. Correct, no? 17 fours are not. 17 threes are. 17 threes are 51. See, it is getting cancelled. So 391 is exactly divisible by 17. Okay. Now 391 is divisible by 17. Therefore, the statement S of n is true for n equal to 1. Now assume the statement S of n is true for n equal to k. Assume the statement S of n is true for n equal to k. That is 3 into 5 to the power 2k plus 1 plus 2 to the power 3k plus 1 is divisible by 17. It means what? Therefore, 3 into 5 to the power 2k plus 1 plus 2 to the power 3k plus 1 equal to 17m, where m is an integer. Now, 3 into 5 to the power 2k plus 1, you will make it as subject always, minus, bring it to this side, 3k plus 1, we will put it as equation 1. Now, to prove this I am going to use, this part I am going to use in next board. Is it clear? Now to prove the statement S of n is true for n equal to k plus 1. For n is equal to k plus 1. Okay, right. So instead of n, you put k plus 1. That is 3 into 5 to the power 2k plus 1 plus 2 to the power 3k plus, sorry, instead of n you have to put instead of n you put k plus 1. 3 into 5 to the power 2 into k plus 1 plus 1 plus 2 to the power 3 into k plus 1 plus 1. This is what? Now see the manipulation. 3 into 5 to the power 2k plus 2 plus 1 plus 2 to the power 3k plus 3 plus 1. Now I will interchange like this. 3 into 5 to the power 2k plus 1 into 5 square, 2 to the power 3k plus 1 into 2 cube. Correct, no? Again, when bases are equal, you add powers, you are going to get the same thing. Now, just now in the previous board I said, this part, 3 into 5 to the power 2k plus 1, what I am going to replace it with? 17m minus 2 to the power 3k plus 1. 17m minus 2 to the power 3k plus 1, right? That whole into pi square plus 2 to the power 3k plus 1 into 2 cube. Now 5 square is 17m into 25 minus 25 into 2 to the power 3k plus 1 plus 2 cube is 8 into 2 to the power 3k plus 1. 17m into 25 minus 25 plus 8 minus 17 to the power 2 to the power 3k plus 1. Now I am going to write 17 common. So 25m minus 2 to the power 3k plus 1. That is 17 into, again I got some integer only, no, without any reminder, right? Therefore, the statement S of n is true for n is equal to k plus. Therefore, by mathematical induction, the statement S of n is true for your n belongs to match. So with this, your mathematical induction is also done. Now we are going to do tomorrow. We are going to do tomorrow. 4 mark and some 2 mark chapters next to 3 to 4 days. Is it clear? That's all. Tomorrow we'll continue. Right? So tomorrow we'll do inverse trigonometry 4 mark and we'll do 2 mark questions. Already I told you matrices already, product of vectors, addition of vectors, all these things we did 2 marks also. Once again, see 2 marks we can't guess. Right? Only the concentration should be on more on 7 and then 4 mark. So that's all. We'll continue tomorrow.